Number one, they ask you to find the inverse. They give you 8x to the third minus 6. To find the inverse, you take the x and y and you... So this right here is the same thing as saying...
Y.
So if I flip them, I have x is equal to...
8y cubed minus 6.
Okay, and I want to solve for...
Y.
Okay, so the first thing I want to do is take the 6 in.
Add it over. 8 plus x plus 6 equals 8y cubed.
I want to divide everything by...
8.
Now here's where you have to be careful. To undo y to the third, you take the... What root of both sides? The cube root of both sides. But here's where you have to be careful, because if you do this, that's okay on one of my tests, but so I'm going to come back up here. X plus 6 over 8. That's fine on one of my tests, but this would not be the choice on the SOL. When you take the root of something, if it's a fraction, you take the root of the top and the root of the bottom. So this is really the cube root of x plus 6 over, and they gave you something you could take the cube root of. What is the cube root of 8?
2.
That's the answer you're looking for. For the second one, if they give you the graph of f of x or the graph of anything, and it says pick a point that you know is guaranteed to be on the inverse. If this is the regular, what's the only point here I can identify? This point right here is 3 comma 0. If I want to know a point that would be guaranteed to be on the inverse, you would take the point and flip-flop the x and y. So if I flip-flop 3 and 0, I would have 1, 2, I would have that one right there, 0 comma 3. Doesn't ask for a graph, it just says click a point that you know is guaranteed to be on the inverse. Another way they could do it is give you 4 graphs and say which graph represents the inverse. Only one of the graphs would have the point 0 comma 3. The next one, they give us comparison between a log and an exponential. In each case, we're looking to graph it, domain, range, and the equation of the asymptote. So for the logarithm one,
Care about left and right.
care about left and right. So do I care about the x minus 1 or the plus 3?
X minus 1.
Okay, so that tells me to go 1 unit to the...
Right.
And make a asymptote. And the log graph would go up and over. Gives me a domain of...
X is greater than 1.
Gives me a range of...
All real numbers.
Gives me an asymptote of...
X equals 1.
Good. Next one. It's the exponential. Do I care about the x minus 1 or the plus 4?
Plus 4.
1, 2, 3, 4. There you go, graph. The domain would be?
Y is greater than 4.
Domain. You
Oh,
give me the range.
domain is all real numbers. Sorry.
The range is
Is
y is greater than 4. And the asymptote is?
Y equals 4.
Good. So that's a logarithm versus an exponential. Okay, they give us something that's quadratic, and they ask us all these quadratic-like questions. The first thing you want to do before you graph this is to do the math. So if you distribute this negative symbol, you would have,
Negative 2x squared plus 3.
so plus 3 and then plus 2 really gives me plus 5. So when you graph this in your calculator, you know it's an upside down parabola, right? And it's also shifted 5 units up. So it would be 1, 2, 3, 4, 5, and then some sort of upside down parabola in your calculator. Is that good?
Yes.
Okay. So looking at this image now that you either have on your calculator or that you wrote down, tell me what the domain would be.
All real numbers.
Tell me the range.
Y is greater than or equal to...
Is it greater than or less than? It's less than because it's going down, right?
Mhm.
Less than or equal to 5. Vertical asymptote, horizontal asymptote. Do we have any of those in a quadratic?
No.
No, so those are gone. The increase and the decrease. Increase and the decrease is the guy that runs from negative infinity. Where does he run to in this case? Is he's running, the graph's doing what? It's going up, and it keeps going up until he hits what number?
5.
No.
Oh, 0.
It's all about the x number, right?
Mm-hmm.
All right, so the 5 is a max or a min, but as far as increase and decrease go, it's going to increase from
From negative infinity to 0.
negative infinity to 0. And then from there, it's going to turn around and decrease from
0 to infinity.
good. And now the end behavior is x goes all the way to the right and all the way to the left. Where do my y's go?
To infinity and negative infinity. To negative infinity to
As x goes to infinity, y goes down. As x goes to negative infinity, y goes, so they both go negative infinity. So you know if it's a quadratic, your end behavior is going to be the same. It's either down, down, or up, up, right?
Mm-hmm.
Keep going. We distributed the negative, so it was negative 2x squared. Minus minus made that plus 3, and then plus 3 plus 2 is plus 5. And then when you graph that in the calculator, you get roughly that graph right there. Okay, they ask you to multiply. So when you multiply, it's a factor, a bridge, and a cancel. Top left corner, top right corner would stay. Top left corner, we would say what? X,
Plus 1. No.
x and x. I want them to multiply to 6, right?
Right.
Okay, so 3 and 2. But I want a positive 1 in the middle as my result, so plus. So we have a 3 and a 2. So if I do plus 3, this would have to be a minus 2.
Right.
This is x and x
X plus 1.
plus 1
X plus 3.
plus 3. And this one is x and x. And I'm looking for a minus 1 in the middle, so this would be minus
2.
2 plus
1.
1. So now we factored, you bridge, and what would cancel?
X plus 3.
X plus 3 and x.
Minus 2.
Final answer, 3x over. Now, when you write this, if you wrote this on a test for me as x plus 1, that's fine. On your SOL, you would be looking for,
Okay.
make sense?
Yeah.
So if it's a squared sign outside, that's like the same thing as saying 2 of them.
Okay.
Good?
Yeah.
Common denominator would be? So up here needs an x. Minus the brackets, because we're subtracting. So this one over here needs an x minus 1. The bottom is quotes. FOIL the top, first times first is 2x squared. That times the outer is 2x, the inner is 1x, so we combine those and get 3x. 1 times 1 is 1. Minus the brackets. When we FOIL this, first times first is 2x squared. The outer is minus 2x, the inner is minus x, so that's minus 3x, and last times last is plus 1. So now we're going to minus the brackets, so distribute the negative. 2x squared plus 3x plus 1. Now this is where you run the negative through. Minus 2x squared minus minus is a plus 3x minus 1. Again, over the bottom. So what's going to cancel? 2x squared minus 2x squared is gone. 1 minus 1 is gone. 3x plus 3x is 6x over. Yep. Good? Okay. Okay, our strategy to solve this is to cross multiply and then solve. So when you cross multiply, it's going to be 4x times 2x minus 1, so we'll write that out. Is equal to 10 times x plus 3. So we cross multiplied. Okay, over here I want to distribute. This would give me
8x
squared
squared, right?
minus
4x
is equal to
10x
plus.
plus 30.
Okay. So you want to pull everything to one side and set it equal to 0. Wherever the squared term will be positive is where I want everything to come. So I'm going to take everything in this case to the left. So I'm going to take the 10x over by subtracting it, and I'm going to take the 30 over by subtracting it. So you have 8x squared. If I subtract 10x over, I already have negative 4, right? So negative 4 minus 10 more gives me negative 14x. Take the 30 over, and I have negative 30 is equal to 0. I want to solve this. It's quadratic. It's squared. I can either factor this or quadratic formula this. If I want to try to factor this, what do you notice? This, and this are all divisible by 2. So if I take a 2 out front, this would leave me 4x squared minus 7x minus 15 is equal to 0. And then I want to see, will this factor? Okay. What's our first guess? What do we want to try here?
Maybe 2x times 2.
All right, so let's try that off to the side, because that is definitely the first guess.
Then plus.
So 15 is going to be 5 and 3, right?
right.
So here's the thing, is that it's a good first guess, but when you do 5 and 3, that's 10 and 6. That's never going to get us to that 7, right? So after we try, we say, okay, that didn't work. So instead of 2 and 2, we're going to try 4x and x. Okay, now again, we have 5 and 3 to work with for the 15. I'm trying to create a 7 in the middle. Well, how could we do that? If I put the 5 here, that's 20. 20 and 3 doesn't do it, right? How about if we do it the other way? If I put the 5 there and the 3 there, the outer's 12, inner's 5. Does 12 and 5, can I find 7 out of that?
Yeah.
And I want a negative 7, so I should let the 12 be negative and the 5 be positive. So I want to take each of these and set it equal to 0. So 4x plus 5 is equal to 0. X minus 3 is equal to 0. X is equal to 3. Subtract the 5, divide by 4. X is equal to negative 5/4. All right, we want the common denominator to be 4x squared. The 2 to 4x squared would get multiplied by 2 and then an x squared. So 2 and an x squared. For this one, it just gets multiplied by x. And for this one, it gets multiplied by 2. So we're going to do the math up top. I have 10x squared is equal to x squared minus 3x plus 2. Get rid of the bottom, solve the top. Bring everything to the, what would be positive here, the left side. So I'm going to bring everything to the left. So I would subtract the x squared. That gives me 9x squared. I'm going to add the 3x. I'm going to subtract the 2. Set it equal to 0. Next strategy is hopefully this will factor. If not, it would be quadratic formula. So first times first is 3x and 3x. 2 and 1 is 3 and 6. That'll work. So I want a positive 6 and a negative 3. Set them to 0. Negative 2/3 would be equal, what you get when you be equal to 0. So x is equal to negative 2/3 and x is equal to positive 1/3. We're going to take a look at this fourth root, and it says write the answer in 2 ways. So the 2 ways to do this is called radical form, and the other one's called exponential form. So if I do it in radical form, this is the fourth root of 16, not the square root. So the fourth root of 16 is 2. Make a root, put a 4 up. So 4 goes into 8 how many times? No remainder. 4 goes into y to the once. It doesn't. 4 goes into z to the third. 4 into 3.
I mean, no, my bad.
So it stays,
Yeah.
and that'd be our answer. Exponential form, fourth root of 16 is, and now what do I do with the letters? 4 and 8, this is power over root, so this is 8 over 4, but 8 over 4 is, so we'll do it in steps. X to the, I wrote that terribly, 2, x to the 8 over 4, which we're going to simplify in a second. Y to the, this is 1, so 4, and z to the, and now we're going to simplify this. 2, x to the 8 over 4 is, which is just 2. And that's exponential form. Good? Problem says x varies jointly with w and y. So your formula would be,
20.
no, hold on, just give me the regular formula.
Oh,
So
okay.
x equals,
KWY.
okay. So now it says x is 20 when w is 2/5 and y is 10. So I'm going to call 10 over 1 so that I have fractions. When you multiply fractions, you multiply the tops and the bottoms. The top would give me, and the bottom gives me, and 20 divided by 5 is, so this is 20 is equal to 4k. Divide both sides by 4 and I get, so now we know k. So we
Yeah.
start over with our formula, but now we know k is 5. Now let's see what they say. Knowing this, find x, so we're finding x when w is 8 when W is 8 and Y is 3/5. 5 times 8 is 40. So I'm going to call it 40 over 1 times 3 over 5. 40 times 3 is 120 divided by 5. And what does that give us?
Oh, you're okay.
Make sense? Okay. Okay, this problem asks for all the vertical and horizontal asymptotes. So this one up here, the first one, you want to factor the top and the bottom, right? So the top would be x and 3 and 1, and I want a -2 in the middle, so I'm going to make this a -3 and a +1. The bottom's the difference of squares, so this is x minus 3, x plus 3. The x minus 3's cancel, right?
Yep.
It doesn't ask for it in this problem, but when you cancel, that makes a what? When you cancel your like quantities, you have a, in the graph, you get a hole in the graph,
Oh, okay.
right?
Sure.
So is that able to be a vertical asymptote anymore when it's a hole in the graph?
No.
Okay, so the only thing that could be a vertical asymptote is what?
X plus 3.
Well, how do I find the vertical asymptote? What do I do to the bottom? I set it equal to,
0.
so what's my vertical asymptote?
-3.
Now, do I say y equals or x equals?
You want X equals.
To find my horizontal asymptote, is it going to be x equals or y equals?
Y equals.
And how do I find my horizontal asymptote? Compare the degree of the top to the degree of the,
Bottom.
and in this case, the degrees are the same, so I take the numbers that are out front, so my horizontal asymptote is at 1. Next one, cube root. Have we learned anything about a cube root graph involving asymptotes? No, none. Okay, so if you wanted to know this, you would try to take a look at the graph. This would be 9 to the right, something or other that looked like that. Either way, it didn't have asymptotes. So if you weren't sure, you would graph it. Okay. Last one's the exponential. The exponential graph, does it have a vertical asymptote or a horizontal asymptote? Let's think about what the graph looks like.
Horizontal.
Horizontal, right? So we gotta know what the graphs look like. So do I care about the x plus 7 or do I care about the number out here?
Up there.
I care about the number out here. There isn't a number out there, right? So in this case, it's plus 0. So this means nothing. This tells me that I have a asymptote at
0.
0.
So then HA is y is greater than 0. Then A
Y is equal to 0.
Y is equal to 0.
It's an asymptote, right?
Yeah.
And there is no vertical asymptote. Does that make sense? So when it's the vertical, I don't care about the x plus 7, I care about the number on the outside. This one didn't have any, and this one we factored the top and the bottom. Problem asks you to solve the following. So the first thing you want to do is take everything and move it to the left. So 6x squared minus x plus 24 is equal to 0. We realized by graphing this that it wasn't going to cross the x-axis, so we need to use the quadratic formula. So I make an A, B, C box. A is 6, B is -1, C is 24. The quadratic formula says negative B, but B is already negative, so it's going to be 1 plus or minus the square root of B squared. -1 squared is 1, B squared minus 4A C over 2 times A. 1 plus or minus the square root of 1 minus 4 times 6 is 24, and 24 times 24 is 576 over 12. 1 minus 576 is negative 575 over 12. We see a negative symbol underneath, so we know there's going to be an I that gets pulled out. We want to find a perfect square, because it's quadratic formula, so this is a square root, a perfect square that goes into 575. And that perfect square is 25. So 1 plus or minus the square root of 25 times 23, and I'm just going to bring the I out. That's what gets rid of that negative, right? over 12. And the square root of 25 is 5. So this is 1 plus or minus 5I root 23 over 12. Now we're done here, but if this number, and this number were all divisible, you would go through and divide. Okay? Okay, 3 problems. First one says we're going to start at 0. If I plug in 0, 1/2 to the 0 is 1. If I plug in 1, I've got a half. If I plug in 2, I've got a fourth. This would keep going. When you have the infinity up top, it's first term, which in this case is a 1, over 1 minus the ratio. The ratio is 1/2. On the bottom, 1 minus a half is a half. Up top, I'm going to turn 1 into a fraction. We flip. Answer is 2 over 1. Answer is 2. Okay. Middle one. First term is 4. I want the fourth term, so I write them out. A1, A2, A3, A4. I want that one. So, first term is 4. This line right here gives me directions on how to find every term. The term before it, 2 times the term before it, plus 1. So if I want to find this one, it's 2 times the one before it, because this means the one before it. So 2 times the one before it's 8, plus 1 is 9. For this one, 2 times the one before it's 18, plus 1 is 19. 2 times the one before it is 38, plus 1 is 39. Okay? 2 times a sub n minus 1. 2 times the term before it plus 1. All right, the third one. First term is 3, so a sub 1 is 3, and they want the fifth term. A2, A3, A4, A5. We want the fifth one. And each time I'm going to add 4. So 7, 11, 15, 19. Okay, the first one, the key to this is realizing that it tells you to start with 2, not 0. Whatever this is right here is what you start with. So if I plug in 2, 1/4 squared is 1/16. If I plug in 3, I have 1/64 plus so on. First term over 1 minus the ratio. The first term is 1/16 over 1 minus the ratio. This is 1/16 over, what is 1 minus a fourth? 3/4. Now we flip. So this is 4 times 1 is 4 over 48. Answer 112. Okay. Second one is a common difference problem. They do not tell you the common difference. You are on your own to figure out that it is plus 5. The other thing you need to know is that A1, A2, and A3 have already been given. 3, 8, 13. I want the seventh one. So A4, 5, 6, 7th. I want the seventh one. And each time I'm going to add 5. 18, 23, 28, 33.